In this session, let us discuss the area of the the centroid of the triangle under coordinate geometry. Let me draw. By the way, what is a centroid? It is where all the medians. Let me draw it properly. When all the medians meet. This is not an accurate figure though. This named as A, B, C. I named the centroid to be O. Obviously, as being in coordinate geometry, this might have a coordinate which I represent by x1, y1, this with x2, y2, and this with x3, y3. The centroid formula is very simple. It is given by the centroid O is given by x1 plus x2 plus x3 by 3, and the y coordinate is given by y1 plus y2 plus y3 by 3. A direct question when you get in under this center of triangle formula, that simply gives you this xy coordinate here for A, B and C respectively, and you are supposed to calculate the coordinate for O applying this formula which I have written. Let us take up some other application on this centroid of triangle. Let me just put up the question here. A is a vertex which is given by 3, 2, and B another one which is given by -2 and 1 are the two vertices of triangle ABC, whose centroid G has coordinates. I could have used, rather I will use the same figure for myself, only changing the centroid which is given here with G, and the centroid is given by the coordinates 5, 3 and a -1/3. We are supposed to find the coordinates of the third vertex C of the triangle. Let me just complete it by writing triangle and like. Okay, so let's take me to this as A, which is given here as 3, 2 in the same figure. I'll just rename the center as G. B is given by -2 and 1, and C, as we are supposed to calculate, let it be as x3, y3. We know that the centroid is given by the formula, this one which I've already written on the board. So I'll just apply that. So x coordinate of the centroid which is given in the question to be 5/3. So this is equal to x1 which is 3, x2 which is -2, and x3 is a question part wherein we have to calculate. This is the x coordinate equivalent. If I solve, I get 5 equals to 1 plus x3. So x3 is 5 minus 1, which is given by 4. Now we'll find the y coordinate. The centroid's y coordinate is given by -1/3, which might have been calculated as y1 which is 2 plus y2 which is 1, and let y3 be as y3 by 3. Again we solve this gets cancelled, so it's -1 equals 3 plus y3. So y3 is equal to -1 minus 3, which is -4. So the vertex C is given by the coordinate 4 minus 4. We now move on to another section wherein we learn to find the area of the triangle when three vertices of a triangle are given. Let us note down the formula first and we learn take up question applying the same. Suppose this is a triangle, A given, B given and C. I give the names to the coordinates of A as x1, y1, B as x2, y2 and C as x3, y3. The formula says area of the triangle is given by half x1 y2 minus y3 plus x2 y3 minus y1 plus x3 y1 y1 minus y2. This is the area of a triangle formula. Here also you can get a direct question wherein these three coordinates are given and you are asked to find the area of the units, and once you find, you write that many square units is your answer. We rather take up another question, not this direct application. Okay, I just need to put up the question though, and to make space, let me just clear this part and write it here. Whatever is the area, you can write it as square units here. Now I will write the question here. It says show that means we have to prove something. Show that the points A, B plus C and B, C plus A and C, A plus B are collinear. That means, how do we prove that these points are in a line? So if we assume that these 3 points are in line, that means they are not forming a triangle. That means if they are not forming a triangle, the area of the triangle should be 0. So we'll try to prove the area of the triangle which might have been formed by these 3 coordinates is given as 0. Once we find that the area is 0, it would prove directly that these 3 coordinates given are collinear. So I'll find the area of the triangle wherein I take this, I'll write below here as x1, y1, this as x2, y2, this x3, y3. We simply apply the formula half x2 is B, y2 minus y3. y3 can, now if you remove the bracket, if I put and remove it, I'll get minus A minus B plus x2 is B and y3 is A plus B. Again the same, I'll change the signs, plus x3 is given by C, y1 is B plus C minus C minus A. Let us see, this gets cancelled, this gets cancelled, even this gets cancelled. I'll just remove the bracket now. So it is, sorry, I made a mistake here. It is x1. I'll just note it down as x1 was A here. So I'm getting it as AC minus AB plus AB minus BC. I'm just removing the brackets, plus BC minus AC. So there is this AC getting cancelled, plus minus BC plus AB minus AB. So the bracket part gets 0, so half multiplied to 0 is a 0. That proves that this is not a triangle. That means these three coordinates are collinear. Now I give you a question, I simply discuss and give you the answers, and I hope you are happy doing that and checking the answer by yourself. It says draw a quadrilateral in the Cartesian plane whose vertices are -4, 5, 0, 7, 5, -5, and 4, -2. It also says find its area. I'll just help you and give you the answer. Help you in the sense how to go for this question. I'm not drawing it in a Cartesian plane, but anyhow the triangle, a quadrilateral if drawn might look like this. And you may say this might be A, this being B, C and D, and I denote them here in the figure as well. As you go for any geometrical figure, divide this into two triangles. You will get one as, either you divide it that way or you can divide it like A, B, C and A, C, D as you wish. See, I made my calculations, I'm just giving you your answer. You will get the triangle ABC area as -29. You'll get the area of the other one, which is given as ACD to be what I calculated, I calculated it to be -31.5. so areas cannot be minus, so let us take it as 29, and here also you can keep it as 31.5. when you add them, your answer will actually be somewhat around 60.5 square units. Happy solving this question, and I hope you get that right. Thank you.